Okay, today in class we talked about the parent functions of the sine graph and the cosine graph. And now I'm going to go into that a little bit more in detail, how we graph trig functions from the parent graphs. Now, to review some vocabulary, we talked about amplitude and period today in class. And amplitude is the height of the graph, and the period is the length of one cycle. The period is the distance it takes to complete one cycle of the graph. So let's look at how we can determine the amplitude and period of the sine and cosine functions. The number located in front of sine and cosine is known as the A value. Okay? And you want to take the absolute value of that, and that determines the amplitude of the function. Now, to find the period, you use the B value. The B value is in front of the x or theta. This could be an x or theta, but it's right there in front of it. And the formula is 2 pi divided by the B value. Okay, and that is how you find the period of the function. Now, I'm about to do these two graphs. That's going to be on the video of showing how to graph sine and cosine function by using the amplitude and period. So that's where I'm coming from at the moment. So if we look at number 1, y equals cosine of 2x. I'm going to write number 2 down. Y equals 3 sine of 4x. Alright, on number 1, the first thing we do is find our amplitude. Our amplitude is the number in front of your cosine. Okay, that is a 1, so the absolute value of 1 is 1. Now I'm going to find my period. It's 2 pi over b. Well, here's my b values in front of my x. That's going to be 2 pi over 2, which equals pi. So the distance it takes to complete one cycle in this particular trig function is a distance of pi. Now we're ready to construct the graph. Amplitude is 1. I will just go on my y-axis and put 1 and -1, because that's how it's going to fluctuate back and forth. Now the hardest part is determining your x values are your x values. What you do is a trick I taught my students is you take your pi, you take your period, not your pi, I'm sorry, your period, whatever's your period, and divide it by 4. Well, if I take pi and divide by 4, it's pi over 4, isn't it? Okay, that is what I'm going to start my x-axis with, and increase my x-axis with. So if I got 1 pi over 4, let me get a pencil for this. This is 1 pi over 4. I'm going to increase by pi over 4, so that's 2 pi over 4. 3 pi over 4. 4 pi over 4. And you say, okay, Mr. Trish, do I need to simplify this? Yes. Now you can simplify this. Okay? So 2 pi over 4 reduces to pi over 2. 3 pi over 4 does not reduce, but 4 pi over 4 reduces to pi. Now, remember we talked about this today that our cosine graph starts up here at your amplitude. Let's review that quickly. Now this is the cosine parent graph. your major points around the unit circle, pi over 2, pi, 3 pi over 2, 2 pi. Okay, and your cosine graph goes like this. That's your general shape of your cosine graph, okay? So you got to know that cosine starts up at amplitude no matter what it is. So right here is this. You come down here, 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 and back up to here. And there you go. There's one cycle. But what I want you to do is to draw two cycles, okay? So we're just not going to draw one, we're going to draw two. But look here, the period was pi, and you see it took, that makes sense because that is the distance to complete one cycle. It has that shape of the cosine, and it started here and into here, so the distance is, to complete one cycle was pi, which is our period, which should have been. Alright, but we want to complete two cycles. So if we complete two cycles, you're going to have 1, 2, 3, 4. You have 4 right here, 5 including 0 at the starting point. So you're going to have, including this starting point, 9 values here. So if I did pi over 4, 2 pi over 3, 2 pi over 4, 3 pi over 4, 4 pi over 4, this will be 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. Okay? Now I cannot reduce 5 pi over 4, but I can reduce 6 pi over 4 to 3 pi over 2, and I need to do that. And you need to do that as well. This is 7 pi over 4. 8 pi over 4 reduces to 2 pi. Now let's talk about why that makes sense. It takes a period of pi to complete one cycle. We're graphing two cycles, so I should end up at 2 pi because one cycle is to pi. Okay? And continue graphing this. Now, of course, you know, this thing keeps going and going and going, oscillating back and forth. So your domain's all in real numbers. Your range will be from -1 to 1, the amplitude. Alright, let's look at number 2. Our amplitude, you can abbreviate that as amp. Absolute value of 3 is 3. My period will be 2 pi divided by b. My b value is 4. So 2 pi divided by 4 is pi over 2. So it takes a distance of pi over 2 to graph one cycle. But before we do this one, let's review the parent sine function. Like we did the cosine up here. Your major points, pi over 2, pi, 3 pi over 2, 2 pi. Sine starts at the origin, goes to the amplitude, back down to the x-axis, down and back up. So remember the difference between the sine and cosine. Cosine starts up at the amplitude, sine starts at the origin. Alright, so you need to know that general shape. Now, so we want to graph this. Amplitude is 3. So I'm going to go up to 3 on my y-axis and down to -3. Now I told you to find your x values. You have to take your period and divide by 4. So watch this now. This was very easy up here. Pi divided by 4 is pi over 4. But here, I'm going to do some math here. Basic math. I take this and I divide by 4. That gives me pi over 8. So that means I took pi over 2 divided by 4, flip, you multiply by reciprocal at pi over 8. So I'm going to start by Okay, I'm going to go and put my tick marks here. Remember, this will be 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Including that origin starting there. Now, I'm going to start with pi over 8 and increase by it. This is 1 pi over 8. 2 pi over 8. 3 pi over 8. 4 pi over 8. 5 pi over 8. 6 pi over 8. 7 pi over 8. 8 pi over 8. Now, I can't reduce 1 over 8, but I can reduce 2 pi over 8 to pi over 4. 3 pi over 8 cannot reduce. 4 pi over 8 is pi over 2. 5 pi over 8. 6 pi over 8 is 3 pi over 4. 7 pi over 8 does not reduce. 8 pi over 8 is pi. And let's see if this makes sense. To complete one cycle, it takes pi over 2 distance. But we're graphing 2 cycles, so should we end up at pi? Yes, we should. Okay, sine. You start the origin, go up to your amplitude, back to the x-axis, down to your amplitude, back to the x-axis, up to the amplitude, down to the x-axis, back down to the amplitude, and back to the x-axis, and graph. Domain will be all real numbers because this thing keeps going this way and this way. We're just graphing 2 cycles. And range would be from -3 to 3 in brackets. Okay. How do I know draw it like this? You look at your parent graph. It starts here, goes up to the amplitude, to the x-axis, down to amplitude, back, and I just follow that pattern. We're going to continue this some more tomorrow in class. This is just an intro. All right. Thank you.